In July 1943, the U.S. submarine Tinosa spotted the Japanese whaler Tonan Maru sailing alone in the Pacific. It was the perfect target, a massive 19,000-ton prize sitting dead in the water with its engines disabled. The captain of the Tinosa, Commander Dan Daspit, moved into a perfect firing position at 800 yards. He fired his first torpedo. It hit the side of the ship with a dull thud and nothing happened. He fired a second, a third, a fourth. He fired 9 torpedoes in total at a stationary target. Not a single one exploded. They just bounced off the hull like giant steel logs. Daspit was so furious that he saved his last torpedo to take back to Pearl Harbor as evidence. This incident exposed the greatest scandal in the history of the U.S. Navy, the Mark 14 torpedo. For the first 2 years of World War II, American submarines went to battle with weapons that simply didn't work. This is the engineering audit of a high-tech weapon that failed in 3 separate, catastrophic ways. To understand the failure, we must look at the culture of the Bureau of Ordnance, BUORD, in the 1930s. The Mark 14 was designed during the Great Depression, when budgets were tight and testing was expensive. A single torpedo cost $10,000, which is roughly $180,000 in today's money. Because they were so expensive, the Navy refused to fire live rounds during testing. Instead, they fired dummy torpedoes filled with water or concrete to verify that they ran straight. They assumed that the exploder mechanism worked because the blueprints said it worked. They never actually blew anything up to check. This pinch-penny mentality meant that the Mark 14 went into production with untested flaws. When the war started in 1941, submarine captains immediately began reporting problems. They would fire at a target, see the bubble trail go right under the ship, and hear no explosion. The first problem was running deep. The torpedo was designed to run at a specific depth, say 10 feet, to hit the vulnerable keel of the ship. But the pressure sensor used to control the depth had been calibrated incorrectly. The engineers had calibrated it using the weight of a warhead filled with water, not high explosive. High explosive is lighter than water. This meant the combat torpedoes were lighter than the test units, so they floated differently. Additionally, the sensor was placed in the rear of the torpedo, where the water pressure was lower due to flow. The result was that the torpedo ran 10 to 12 feet deeper than set. If a captain set the depth to 10 feet to hit a destroyer, the torpedo would run at 22 feet. It would pass harmlessly under the keel of the enemy ship, leaving the submarine exposed. When captains complained, the Bureau of Ordnance blamed the captains. They claimed the officers were calculating the range wrong or aiming poorly. Admiral Charles Lockwood, the commander of the submarine force, didn't believe the Bureau. He conducted his own rogue tests in Australia. He fired torpedoes through a fishing net submerged in the water. The holes in the net proved that the torpedoes were running 11 feet deeper than set. Faced with the evidence, the Bureau finally admitted the error and issued a fix. But as soon as the depth problem was fixed, a second, worse problem appeared: the magnetic exploder. The Mark 14 was designed with a secret weapon, the Mark 6 magnetic influence exploder. The idea was that you didn't need to hit the ship directly. You could shoot under the ship, and the magnetic field of the steel hull would trigger the detonator. An explosion under the keel is far more deadly than an explosion on the side. It breaks the ship's back, snapping the keel and sinking it instantly. But the magnetic exploder was too sensitive. It was tested in New England, where the Earth's magnetic field is different than in the Pacific. In the combat zone, the torpedoes would explode prematurely, 50 yards away from the target. Or they wouldn't explode at all. Captains reported seeing their torpedoes detonate halfway to the target, alerting the enemy. The Japanese destroyers would then turn and drop depth charges on the helpless U.S. submarine. Admiral Lockwood ordered his men to disable the magnetic exploder. The Bureau of Ordnance was furious, ordering them to keep using it. It became a bureaucratic war between the men fighting and the men sitting in Washington. Eventually Lockwood won, and the magnetic exploder was deactivated. Now the captains were told to aim for contact hits, hitting the side of the ship directly. This revealed the third and most tragic flaw: the contact exploder. This is what happened to Commander Daspit and the Tonan Maru. When the torpedo hit the steel hull of a ship at a perfect 90-degree angle, it didn't explode. It was a cruel irony of physics. The firing pin mechanism was too heavy and the guide tracks were too fragile. When the torpedo hit the target at 46 knots, 53 mph, the deceleration force was immense. The impact was so violent that the guide tracks for the firing pin crushed and jammed. The firing pin couldn't move forward to hit the primer. Essentially, the torpedo hit the ship too hard to explode. It was a dud because it was a direct hit. If the torpedo hit at a glancing angle, oblique hit, the impact was softer and it might work. But a perfect shot, the mark of a good captain, resulted in failure. The Bureau of Ordnance again denied the problem. They said, "It is impossible for the exploder to fail." Admiral Lockwood was forced to conduct another rogue experiment, famously known as the cliff test. He took live torpedo warheads and dropped them from a crane onto a steel plate. He dropped them from a height that simulated a 46-knot impact. 7 out of 10 warheads failed to detonate. They cracked open, spilling high explosive on the ground, but the firing pin never moved. Finally, in late 1943, nearly 2 years into the war, the problem was identified. The solution was incredibly simple. They needed to make the firing pin lighter and the spring stronger. They effectively rebuilt the exploder mechanism using light aircraft alloys. Once these fixes were implemented, the Mark 14 became a lethal weapon. In 1944 and 1945, US submarines strangled the Japanese economy, sinking the merchant fleet. But the cost of the delay was horrific. For 2 years, US submarines had risked their lives to deliver duds. How many submarines were lost because their torpedoes didn't kill the destroyer hunting them? We will never know the exact number, but it is certainly non-zero. The most tragic story involves the USS Tang and her captain, Richard O'Kane. The Tang was the most successful submarine of the war. In October 1944, during a surface battle, the Tang fired its last torpedo, a Mark 18 electric version. The torpedo malfunctioned. It breached the surface and began a circular run. The crew watched in horror as their own torpedo turned around and headed straight for them. It struck the stern of the Tang and exploded. This wasn't a failure of the detonator. It was a failure of the rudder control. But it highlights the inherent danger of trusting complex, unverified technology. The Mark 14 scandal serves as a case study in institutional arrogance. The engineers in Washington refused to believe the data coming from the field. They trusted their theoretical calculations more than the eyewitness reports of combat veterans. They created a feedback loop of denial. When a captain reported a miss, they assumed the captain was incompetent. This protected their egos, but killed the sailors. The scandal also highlights the danger of gold-plating weapons. The Mark 14 was designed to be the most advanced torpedo in the world. It had variable speed settings, a steam turbine engine, and a magnetic detonator. It was a marvel of clockwork engineering, resembling a Swiss watch. But in war, you don't need a Swiss watch. You need a brick. The Japanese long-lance torpedo was simpler, bigger, and far more reliable. It used pure oxygen for propulsion, giving it incredible range and speed. While the Americans were debugging their firing pins, the Japanese were sinking carriers. The economic impact of the failure was also massive. A submarine patrol cost hundreds of thousands of dollars in fuel, supplies, and wear. Sending a sub all the way to the coast of Japan to fire dummy warheads was a waste of strategic assets. It effectively demilitarized the US submarine force for half the war. The fix, when it came, was practically free. Machining a lighter firing pin cost a few dollars. The gap between the cost of the failure, lost ships, lost war duration, and the cost of the fix is staggering. It proves that the most expensive part of engineering is admitting you are wrong. There is a lesson here about simulation versus reality. The Bureau tested in calm water with dummy heads in New England. They did not test in rough seas with real explosives in the tropics. They tested for the conditions they wanted, not the conditions that existed. The Tonan Maru incident remains the perfect symbol of this failure. Imagine the frustration of Commander Daspit. He had done everything right. He had navigated through minefields and dodged patrols. He had maneuvered his boat into the perfect firing solution. And then, clunk. He later said that when he returned to Pearl Harbor, he was ready to strangle the admiral at the Bureau. His anger, and the anger of thousands of submariners, finally forced the change. It forced the Navy to adopt a test it until it breaks philosophy. This philosophy would later serve the US well in the Cold War and the space race. But in 1942 and 1943, the learning curve was written in blood. The Mark 14 torpedo eventually sank 4 million tons of Japanese shipping. It starved the Japanese war industry of oil and rubber. It did its job, eventually. But the ghost of the scandal years haunted the submarine force for decades. It reminds us that high-tech weapons are useless if the basic mechanics fail. A magnetic exploder is a technological wonder. A firing pin is a simple mechanical nail. If the nail doesn't work, the wonder is worthless. The Mark 14 failed because it tried to be too smart. It tried to outsmart the enemy with magnetism, but failed to do the simple job of banging a percussion cap. It was a weapon designed by scientists, not soldiers, and it took a war to teach the scientists that the lab is not the ocean. So, the next time you hear about a new, expensive military technology, ask the question, has it been tested in the mud? Because if it hasn't, it's just a $10,000 hypothesis. And as the crew of the Tinosa found out, you can't sink a ship with a hypothesis. You need a working hammer. And for 2 years, the US Navy didn't have one. The Mark 14 remains the gold standard of engineering arrogance, a $1 billion program defeated by a simple physics calculation they forgot to check.